Good morning everyone. My name is Arslan and you are watching Proper Tech Tutorial. So welcome back to the series of learning siemensnx from beginner to pro. And today we'll be starting the part 32, that is basic assembly constraints, part 2, part 3 that will deal with the following. I'll just show you the syllabus and we'll start without any delay. So today we'll be covering part 32, that is this, and just a moment, and now it is all set. So parallel constraint, perpendicular constraint, and align and lock constraint. So without any further delay, let's start first with the parallel. So what we will do is that the parallel constraint and the perpendicular constraint. Okay, so now what I will do is that I'll just use the assembly constraint and I will take this body, take this particular constraint of parallel, and I will select this face. I will select the other face to be this, and I will click on apply, and you will see that the degree of freedom of this particular part has changed into, it has decreased the circular degree of freedom that was around the y-axis. For example, if I want to rotate this object in this fashion, it will not get rotated. You understand that? It will not get rotated. So that is something that is like to be understood. Now I'll just use the cursor and take it over here. It will still be parallel. I'll click on apply and then click on cancel. After that, what I'll do is that I want to like align it over here. So can it be done using parallel, perpendicular and align lock constraint? Let us look into that. I'll open the assembly constraint. I want the thing to be parallel. So is it required to make it parallel? Let us see. If I move it in this fashion, or if I move it in this fashion, yes, it needs to be applied the perpendicular. So I'll just discard it, or what I can do, I'll just go to the align part, assembly constraints, and I will select the align lock. After that, I will select the center of this part and I will select the center of this part, and you can see that both the center lines have got aligned with each other. And now if I try to show you the degrees of freedom, you can see it has only 1 degree of freedom, that is around the y-axis, the linear translational degree of freedom. If I try to move it, you can see that it will only move in this fashion. Now if I want, I can either restrict it using the fixed distance, the fixed distance method, or the fixed method, or I can just touch it using the touch method, whatever it may seem fit with me. So that is up to you. Another thing is the perpendicular constraint. So perpendicular constraint as of now will not be necessary, because this thing is not moving in a manner that it will require the perpendicular constraint to be used. So what we'll do is that we'll just use another constraint. Did my degree of freedom? Yes, the constraint was successfully applied on line lock. Now assembly constraint, I will just use the touch align. I will click on preferred touch or touch directly. I will select this face, I will select this face, and now the nut has been totally screwed inside. Coming to the part of perpendicular. So perpendicular constraint allows two things to be in perpendicular with each other, or making 90-degree with each other. That is, if you see the degrees of motion for this particular object, you can see that it can move in the x, y and z axis, and it has rotation in about all the three axes that are existing. So what I will do is that I will just use the assembly constraint. I will select the perpendicular constraint. I will select this. I will refresh it. I will select the perpendicular constraint. I will select this face and I will select this face and I will click on apply, and you will see that the degree of freedom has changed in this fashion, that now it cannot rotate about the it can rotate about the z-axis, it can rotate about y-axis, but it cannot rotate about the x-axis because now it is perpendicular. So if I will try to move this particular object, if I will try to move this particular object and I try to rotate in the x direction, it will not rotate in the x direction. It can rotate in this direction, it can rotate in this direction, it can rotate, it can translate in this direction, but it will not rotate in the about the x-axis. Next, what we can do is that after making it perpendicular, what I want is that I want to make it aligned with this hole. So I will use the assembly constraint, I will use the align lock constraint, we can use the concentric, we can use the touch align, we can use the parallel, we can use any of them, we can use the peripheral infer center axis. So as of now we are studying the infer, the align lock we will be using only that. So I will select this particular center axis and then I will select the center axis of this nut, and you will see that it has taken the position for the as per the infer center axis. I show you the degrees of freedom and you see that only 1 degree of freedom remains, that is the linear translational motion, or the perpendicular thing might be deleted and still the degrees of freedom will be the same, that is only the y-axis. So align log allowed us to align the center axis of the nut with that of the fixed pin, and that allowed us to make it like constrained in multiple objects in multiple areas, and now only y-axis remains. So for that what we can do is that we'll just click on the assembly constraint, the parallel, okay, align lock, okay. So this cannot be done by by using only these three. So I'll have to use the touch align or I'll have to use the concentric. Either of the two I will have to use that. So I'll just select the touch. I will have to select the face, another face, and now it is totally constrained. You can see the part position status and you will get the idea as to which position is fully constrained and which position is fixed. So with this we come to an end of part 32, that is parallel, perpendicular and align lock constraint. In the next video we'll be dealing with part 33, that is fit, bond and center constraint. So in the next video we'll be dealing with these, and after that we'll be dealing with the advanced assembly constraints such as hinge, slider, etc. So if you like our videos, do subscribe and hit the bell icon, like our videos, subscribe our channel, comment in case you find anything that we should do, any modifications, any changes, any things that which we are doing good at. You can also like congratulate on that, give us a thumbs up. Till the next time we meet, goodbye.